In this video, we're going to look at the idea of location, velocity, and acceleration, and how calculus ties into these physics concepts. So first off, what are they, and how are they connected? So, location is basically just where an object is. And oftentimes, I'll see that written as x of t, sort of a horizontal location with respect to time t, y of t, sort of a vertical location with respect to time t, or h of t for like a height. I can also consider this as displacement as well. Displacement and location will function very similarly. And displacement, a lot of times, uses an s. Now, next thing is velocity. And velocity is the rate of change of location over time. And a rate of change in calculus is just the derivative. So the derivative of location with respect to t. And a few things to talk about before we go on to the next idea here. It's important to note that we will allow the location, if I'm talking about a one-dimensional location, like a number line, it can be positive or negative. And because of that, my velocity can also be positive or negative. Velocity that you deal with in science class and in calculus a lot is not the same thing as what you see on your car's speedometer. And we'll get to that in a second. Now, in here should also make sense. An example unit for location, so example unit, could be something like meter. When I take the rate of change of this with respect to time, the units will often end up being something like meters per second. Before I go on to acceleration, I have to talk about something else here, and we sort of refer to it, speed. So the speed is just the magnitude of the velocity. And I'll oftentimes use the v variable for velocity. So in a one-dimensional concept, it will always just be positive, but this magnitude, this absolute value, does expand up well to two-dimensional and three-dimensional when we start talking about the magnitude of a vector and that type of thing. Alright, finally for this slide, acceleration. And this is just the rate of change of velocity over time. And so the variable usually used will be a of t. And that's going to be the derivative of v with respect to t. Or, since v was the first derivative of x, this will actually be the same thing as the second derivative of location with respect to time. And you can notice the units. Well, if velocity was in meters per second, and I'm taking the rate of change of this with respect to time, we're going to get something like meters per second, or meters per second squared. Again, it's just an example. I could have kilometers, I could have minutes, hours, but that's the type of thing we see. Alright, let's see an example of just using these. So I am given the location, measured in meters, t is measured in seconds. I want to find the location, velocity, and acceleration when t is 2 seconds. So to find the location, let me actually notate that. So for location, well, I just use x of t. So evaluate x of 2, which is going to be 2 cubed minus 3 times 2 squared plus 2 minus 4. 2 cubed is 8. 2 squared is 4, times negative 3 is negative 12, plus 2 minus 4. And it looks like let's see, 8 minus 12 is negative 4, plus 2 is negative 2, minus 4 is negative 6, and that is in meters. Next up, we need to find velocity, and it'll be very useful to find the velocity function. So v of t is just going to be the derivative of this. So it'll be 3t squared minus 6t plus 1. And so I can find v of 2, because I want to know what the velocity is at 2 seconds. And that will be 3 times 2 squared minus 6 times 2 plus 1. 2 squared is 4, times 3 is 12. 6 times 2 is 12. And so I get the velocity is 1 meter per second, because I took this derivative with respect to t. And then finally, acceleration. I can just take the derivative of the velocity function. So a of t will equal 6t minus 6. And evaluate this at 2, which is going to be 6 times 2 minus 6, which is 12 minus 6, which will be 6. So the acceleration is positive 6 meters per second squared. And that's a little direct example of using this. Now, on to a question that happens on a lot of AP tests, and that is something speeding up or slowing down? And first, let me put what's wrong to do. I see this way too often. So the wrong thing is to find a of t, and then say if a of t is greater than 0, it's speeding up. And if a of t is less than 0, it's slowing down. And this is not correct. Here's the reason. If a of t is bigger than 0, that means the velocity is increasing. If a of t is less than 0, that means the velocity is decreasing. But speed and velocity are not the same thing. So here's the correct way to do it. So first, you would find v of t and evaluate at the given t value. Second, find a of t and evaluate. And finally, if they have the same sign, both positive or both negative, that means that it's speeding up. I'll explain why shortly. And if they have a different sign, one's positive, one's negative, then that means it is slowing down. And here's why. So let's say right is positive, left is negative, and we'll have the velocity, we'll have the acceleration. If it's moving right and accelerating to the right, it'll be moving right faster, speeding up. If it's moving right but accelerating left, it will be moving right at a slower and a slower rate, because this acceleration will be taking speed off of it. So this will be slowing down. If it's moving left but accelerating right, then that means that this will be taking speed off it. I'll be getting closer and closer to a 0 velocity, so slowing down. But if it's moving left and accelerating left, then as time goes, it'll be moving faster to the left, so this will be speeding up. Here's an example. So I'm given the location y of t, so sort of a height, is equal to sine of 2t, and I want to know is the particle speeding up or slowing down at t equals 5 pi over 8. So here's what we do. We find the velocity, which is going to be the derivative of this. Derivative of that is cosine of 2t times 2, and I evaluate this at 5 pi over 8. Two times 5 pi over 8 is 5 pi over 4. the cosine of 5 pi over 4, let me draw the little unit circle. 5 pi over 4 is over here. The cosine, which is the x value, is negative root 2 over 2. So I have negative root 2 over 2 times 2, which is negative root 2. Now, it doesn't matter that this magnitude is root 2 for this question. What matters is it is negative. Next, I'll go to the acceleration. And so the derivative of this will be negative sine of 2t times this constant multiple of 2, but also times 2 for this chain rule, which I guess I'll clean this up, is going to be negative 4 sine of 2t. And I could have cleaned this up and said 2 cosine 2t. And now I'm going to evaluate this acceleration at 5 pi over 8. So I have negative 4 times the sine of 2 times 5 pi over 8 is 5 pi over 4. The sine of 5 pi over 4 is also the y value, negative root 2 over 2. So I have negative 4 times negative root 2 over 2, which is positive 2 root 2. And what this means is, since they have, let me actually write this out. Since b and a have different signs, the particle is slowing down. It is moving, since we're doing y, it's moving down, but accelerating up, which means as time goes, it'll be moving down more slowly until eventually, if this acceleration keeps up, it will stop moving down and then start moving up. All right, I hope this helped out. Feel free to comment below if you do have any questions.